Morning, sir. First of all, thank you so much, sir, for giving this opportunity to review on our project. The project, the title of our project is Permanent Magnus Synchronous Generator Wind Energy Conversion Systems with Jet Source Inverter under the estimated guidance of Mr. G.M. Subban, MTech, presented by G. Surendra Reddy, Y. Veera Reddy, G. Sudhir Kumar Reddy, G. Vishnuvardhan Reddy, M. Srinivas Reddy. In this project, first we are mentioning the outlines or abstract, introduction, current scenario, objective, basic topology, proposed control strategy, and conclusion. First of all, we are going to discuss about the abstract. The recently permanent magnet synchronous generator are mostly used in the wind energy conversion systems applications. This work is clearly deal with the study of wind energy conversion systems WECS by way of permanent magnet synchronous generator PMSG with jet source inverter. The PMSG and wind turbines are gradually entered in the field of power generation. Huge forms and are used to constant voltage and frequency to increase the capacity of power. Introduction. First of all, we are going to introduction this project. Increasing the population and depletion of fossil fuel. Carbon emission reduction is a global agenda. Renewable energy sources like solar, wind energy, and hydro energy are leading the power producers in upcoming years. Current scenario: the total installed capacity in India 36.625 gigawatts. India ranks the fourth in terms of total installed power of wind energy. Objective: to design and validate efficient control strategies for enhanced operation wind energy system, to mitigate the power to the rated value during the high wind speed region, to extract the maximum available power from the available wind velocity, the regulate the DC link voltage and active power of the generator. The DC link, it is very important parameter which is used in our project. Basic topology. The basic topology: first, when there is a flow of wind turbine, the wind turbine is going to be rotated and it is generated the AC power supply, and AC power supply is transmitted to the machine side converter and it is converted to the grid side converter. By these two are interconnected by the DC link capacitor. Proposed methodology: using PMSG and jet source inverter using with grid connected system. For example, when there is a flow of a certain amount of wind, the turbine will be rotated, and rotated turbine will be rotated and converted into three-phase AC supply, and this three-phase AC supply is converted into the DC supply by using rectifier, and DC supply is connected to the boosted DC supply, and boosted DC supply is transmitted to the AC power supply, and the AC power is connected to three-phase AC power supply. By using this three-phase AC power supply, we can consume the power. The working principle, the main of the project, the working principle: the permanent magnet synchronous generator rotor rotates and generates AC power supply. This AC power supply is directly fed into the direct rectifier, the rectifier which converts the AC power supply to the DC power supply, and DC power supply which is boosted and it is again converted to the AC power supply. Topology of jet source inverter. By seeing this diagram, these two are jet source impedance network and main circuit. These are coupled together. It has two networks, for example L1 and 2 split inductors like L1 and L2, and capacitors. We have two capacitors, that is called C1 and C2, and there are two modes of non-shoot through switching state, non-shoot switching state, and shoot through switching state. These above modes are represented in the waveforms. The power quality improvement using permanent magnet synchronous generator and jet source inverters. The basic methodology using PMSG and jet source inverter. Above the block diagram we have discussed, the power supply is rectified into DC supply, and DC supply is again rectified into boosted, and it is converted into AC supply, and we can use that power. It is continued. Simulation nation. This is the block diagram. This is not only block diagram. By using this network structure, we are going to simulate our project. For example, we have mentioned some parameters like 480 volts and 50 Hz and grid, and change in load active power, and source active and reactive power, load PF and source power factor. By mentioning all the parameters, and this circuit is going to be connected in the comment window, and we simulate the results by using the 0.1 millisecond of time. This is the parameters which are actually, these are the parameters we have used: boost converter parameters, inverter parameters. For example, we have implemented these parameters in our simulation result. The inductor, output capacitor, diode switching frequency, filter inductor, filter capacitor, phase voltage switching frequency, and DC link voltage. And we, by entering the 0.1 millisecond, we are going to this kind of graph. Not exactly we are going to get this graph. There is some fluctuations is happened according to what we assigned to the parameters. The simulation results regarding of a permanent magnet synchronous generator output and rectifier output voltage, and simulation results depend upon capacitor voltage and TH total harmonic distance, active and reactive power of source. And we got these kind of graphs regarding there are 4 parameters. For example, permanent magnet synchronous generator, we have plotted the graphs, and active and reactive power we have plotted the graphs, and total harmonic distortions we have plotted the graphs, and we also plotted the power factor, and we also plotted the time versus revolution per minute or round per minute of wind turbine. The parameters we have used on this conventional method, proposed method. There is a one major difference between conventional method and proposed method. We in this proposed method we are developed the or increase the parameters, and by using maximum constant boost control with third harmonic injection method. Conclusion: the conclusion is the project is mainly focused on power quality improvement of wind energy. The main motto of our project is to improve the power quality of wind turbines and to give the best and efficiency power to the consumer. Thank you for so much giving this opportunity to introduce our project to everyone. Thank you so much.